can you use statistical measures to compare and draw conclusions about two sets of data? Think about this question during the lesson. Azul collects data twice, a year apart, from a group of students participating in a youth fitness program. How can Azul use the mean, range, and data distributions to compare the data sets? Step 1. Use line plots to compare the data sets visually. The data set for burpees completed last year peaks a 24. The data set for burpees completed this year peaks a 28. A peak or high number of data points on a line plot can be used to describe and compare two data sets. Step 2. Use the line plots to compare the data sets. The mean of the data set for burpees completed last year is 23 and 6/10. The range is 7. The mean of the data set for burpees completed this year is 26 and 6/10. The range is 9. The difference of the means and the peaks show that the typical number of burpees done this year is about 3 or 4 more than last year. Which data set has more variability?
Select your answer.
The range for this year, 9, is greater than the range for last year, 7. There is more variability in this year's data than in last year's data. Azul also collects and graphs data about completed push-ups. For which year's data does it appear that the mean is greater? Explain.
It seems that the mean is greater for this year because if you look at the line plots from last year to this year, last year started at 1 and they go to 10. The majority of the points are right here, 3, 4, and 5, right? And then this year, the dots data starts at 3 and there's some data at 12. And the majority of the numbers of completed push-ups are 7 and 8. So just based on that identity, you see that this year's data would appear to be greater.
The 7th and 8th grade students planted butterfly bushes this year. Each grade recorded the number of butterflies seen at their bushes. How can you use the median and IQR to describe the data sets?
Seventh grade median is 24. You notice that from here. 8th grade median is 21. That is about here. So 24 is greater than 21. The 8th grade IQR is 9. Where's 8th grade? Here's the IQR about there. And then you have the 7th grade IQR at 6. And then 9 is greater than the 6. The 7th grade butterfly bushes attracted more butterflies and had a more consistent amount of butterflies seen at their bushes.
Mario tracked the 400 meters running times of a group of African and Caribbean runners training for a junior indoor track and field event. What conclusions can he draw about the data by comparing the mean, range, and distributions of the data sets?
African runners, 400-meter statistics in seconds. Mean running time, 52 and 5/10 seconds. Fastest running time, 50 seconds. Slowest running time, 55 and 8 tenth seconds. Then you have the Caribbean runners 400 meter statistics. The mean running time is 52 and 7 tenth seconds. Fastest running time is 51 and 1 tenth seconds. Slowest running time is 55 and 2 tenth seconds. And then you have your mean. The African runners mean here is less than the Caribbean runners mean. Then you have your range. The African runners range would be their fastest time subtracting their slowest time, and their range is 4 and 1/10 for 5 and 8/10 for the African runners, and 4 and 1/10 for the Caribbean runners. And so the African runners range is greater than the Caribbean runners range. So Mario can conclude that there is more variability in the African runner's time than the Caribbean runner's time. Then you look at the distribution. Mario can conclude that some of the African runners are faster than some of the Caribbean runners.
How can you use the data in the histograms to compare and interpret the scores for test number 1 and test number 2?
There are a few different ways that we can compare the data. For one, you see that for the test number 2 scores, no one scored an F. There's no one in that 50 to 59 range there, but for test number 1, you have at least one person that scored that. So that's one way to compare. They did better on the test number 2. Also, another thing you can compare is the mode, if you will. The number of people that scored the most is between 70 and 79 on test number 1, and the median here for the test number 2, more scored between that 80 to 89 range. So you would say that for test number 1, there was the least amount of variability here, but in test number 2, there was less variability in test number 2 than there was in test 1. You have a lot of variety here, a lot more spread out, whereas in test number 2, they're more toward the higher side of the range of data.